Two teams analyzed one spectrum, found opposite worlds. Identical photons, completely opposite conclusions about alien life. Right now, no one knows which conclusion is correct. The gravity matrix. Today we follow the photons across 73 light-years. Here at the gravity matrix, the spectrum stopped us. In 12 minutes you will understand what this spectrum means. Flash forward. What JWST found at 3.5 microns changes everything. The Cambridge team found methane at 6 sigma, bulletproof confidence, carbon dioxide at 3.9 sigma, something at 3.5 microns unexpected. Montreal ran the same JWST data through different models. Their answer: no ocean, no Hycean world at all. Both papers peer-reviewed, same instrument, neither team retracted. TOI-270d, a sub-Neptune 2.2 Earth widths, 73 light-years. It orbits TOI-270, a quiet M-dwarf with low flares. TESS found this system in 2018, 3 prime targets. Innermost planets too hot. TOI-270d is the candidate. Orbital period: 11.4 days. Terminator temperature: 323 Kelvin. 323 Kelvin, warm enough for liquid water potentially. Madhusudhan coined Hycean world in 221. It's 2 atmosphere over ocean. He predicted JWST's fingerprints. TOI-270d delivered them. Constantinou ran the retrieval algorithm for months. Same signal. Methane at 6 sigma, a wall of statistical confidence. Carbon dioxide at 3.9 sigma. Water vapor at 2.1 tentative. Ammonia, conspicuously absent. That silence is the key evidence. On Earth, oceans absorb ammonia, depleting it from atmosphere. CH4CO2 disequilibrium without NH3 matches. Ocean world model predictions. Constantinou, Terminator at 323 Kelvin. Cooler than Benneke's 385. That 62-degree gap determines whether liquid water exists at all. Not the data. The model assumptions drive the answer. The real investigation: 3 threads decode what the spectrum means. Thread 1. The Cambridge case for a Hycean ocean world. NIRISS plus NIRSpec covered TOI-270d from 0.6 to 5.2 microns. That range is the chemical fingerprint zone for biosignatures. 6.4 sigma methane. Virtually zero probability this is noise. At 6 sigma, the particle physics standard, methane is confirmed. Methane plus CO2 and hydrogen, their coexistence is significant. In equilibrium chemistry, methane and CO2 rapidly destroy each other. Their simultaneous presence demands a replenishment source below. On Earth, life continuously produces exactly this disequilibrium. Constantinou built the retrieval code that finds these signals. Running the algorithm a third time, the DMS signal persisted. The 3.5 micron signal could be ethane or dimethyl sulfide, ethanase abiotic, produced by atmospheric photochemistry. On Earth, dimethyl sulfide comes almost entirely from marine phytoplankton. Marine microbes exhale it. No major abiotic source matches. If that 3.5 micron signal is DMS, Cambridge found a biosignature. 2.1 sigma, not a detection. Significant enough to track carefully. The team sent results to Madhusudhan. They checked for errors. Twice, no calibration error. The signal survived every systematic check. In our assessment, this is astronomy's most important unresolved biosignature. If this shifts your view of the cosmos, subscribe. What if life's signature molecule showed up 73 light-years away? DMS, dimethyl sulfide, made primarily by marine microbes. JWST found a tentative 2.1 sigma signal at the right wavelength. 3 abiotic pathways: ethane masking, photochemistry, volcanic ceasetuo. None fully explains the signal. The frontier is genuinely uncertain. Biosignature frontier in 2026. Full breakdown pinned in the comments. Thread 2, the case against Benneke, Université de Montréal. Benneke's framework found a fundamentally different planet entirely. His retrieval returned 5.47 atomic mass units mean molecular weight. Higher mean molecular weight, heavier molecules dominate the atmosphere. Heavier atmosphere means higher pressure, incompatible with Cambridge's ocean. Benneke calculated terminator temperature at 385 Kelvin, not 323. At 385 Kelvin, 112 Celsius, liquid water cannot persist. Same data, different temperatures. Which retrieval model is wrong? Neither is provably wrong yet. Both fit the observed spectrum. Science at epistemic limits, not failure, the process working. The K-10b precedent hangs over every number in this debate. The turn approaches. Luquet's K-10b finding changes the stakes. The next thread complicates everything the last 20 scenes established. Thread 3. How code TOI-270d's shadow falls on TOI-270d. In 2023, Madhusudhan announced a tentative DMS detection in K218. NIRCam data showed a signal consistent with DMS or DMDS. One instrument can miss systematics. The claim needed confirmation. Raphael Luque assembled a joint team, NIRSpec, and NIRISS and MIRI. 3 instruments, same planet, better coverage to 12 microns. Luque's team published August 2025, insufficient evidence for DMS. Real signal, but the DMS interpretation did not survive. That result now lands directly on TOI-270d's claims. Frontier science. The first case refines and challenges the second. TOI-270d has NIRISS plus NIRSpec joint coverage from the start. 0.6 to 5.2 microns, DMS and ethane distinguishable. 2.1 sigma. Real but barely above the instrument's noise floor. Could the star's UV be faking the DMS signal? M-dwarf UV could drive sulfur chemistry producing DMS-consistent signatures. Strongest abiotic counter, and Cambridge acknowledges it explicitly. K-18b reanalysis weakens the DMS claim, but not eliminates. Preprint versus peer-reviewed matters here. Both analyses now peer-reviewed. Constantinou et al. Published in Astronomy and Astrophysics, January 2026. Watershed dataset not the conclusive answer either team hoped. Dark Hycean scenario. Even tidally locked worlds may host oceans. On the permanent night side, temperatures drop into habitable range. Dark Hycean concept expands which planets can support liquid water. TOI-270d gets more radiation than K218b, harder to sustain. Benneke's strongest argument. Energy budget, not the retrieval model. April 2025 geochemical paper. A fourth interpretation. Sulfur atmosphere. Geochemical models suggest the sulfur chemistry may be purely geological. Peak moment. 3 competing interpretations from 173 light-year signal. Cambridge, ocean. Montreal, miscible envelope. Geochemistry, sulfur atmosphere. All 3 fit the JWST data. Extraordinary and troubling. Transmission spectroscopy alone cannot distinguish ocean worlds from hot rocks. Past this limit, models alone decide and they disagree. Assumption 1. Are H2-dominated atmospheres allowed as free parameters? Assumption 2. How to correct for stellar spectral contamination, morph spots and faculae autoplanetary transmission signals. Different contamination corrections cascade into opposite temperature results. Both teams operated correctly within their methodological frameworks. We do not yet know which retrieval framework is accurate. That uncertainty makes this moment in exoplanet science consequential. The meaning comes from what follows, the final thread. Here is what TOI-270d means for the galaxy's light inventory. Sub-Neptunes are the galaxy's most common planet type by far. Kepler counted them. Roman Space Telescope will count vastly more. For decades, habitable zone thinking centered only on rocky worlds. What if the galaxy's most common planet type supports life? Sub-Neptunes outnumber Earth-sized worlds roughly 3-1. If sub-Neptunes host oceans, the galactic habitable zone expands. TOI-270d tests whether Hycean worlds are real or theoretical artifacts. One confirmed Hycean world transforms galactic life probability entirely, from seconds billions to far more, if models hold. Here is the framework. What to watch for next. If MIRI detects C/O above 5 sigma, sulfur atmosphere strengthens. A third team replicating 323 Kelvin, Benneke's 385 falls. DMS above 3 sigma in Emiary, biology becomes genuinely likely. DMS absent in MIRI, ethane wins, Hycean pathway closes. We watch science working at the instrument's epistemic boundary. Cambridge versus Montreal, not scandal but the process functioning. Madhusudhan has spent 15 years building this theoretical framework. His 2021 Hycean paper predicted exactly the fingerprints JWST detected. Whether ocean or hot rock, that question stays open. Ammonia non-detection. Oceans absorb NH3, depleting it from atmosphere. On an ocean world, ammonia dissolves from the atmospheric record. TOI-270d's NH3 upper limit matches ocean world predictions remarkably. Not proof of an ocean, but consistent with one. Måns Holmberg built the observational case from TESS to JWST. The TOI-270 program spans years. A sustained scientific campaign. The definitive answer almost certainly requires MIRI mid-infrared observations. MIRI observations will likely close one interpretive door permanently. Data suggestive but not conclusive. Responsible science says so. We may see life's chemistry, or an interesting rock. Both teams prove JWST can detect the chemistry that matters. JWST, launched December 2021, now reads atmospheres worlds away. The Apollo generation watches JWST read atmosphere 73 light-years out. Sagan asked, "Are we alone?" JWST now searches for answers. TOI-270d may be the practice run before confirmation arrives. If 1% of sub-Neptunes host oceans, not alone. The iron in your blood may mirror TOI-270d's chemistry. Two teams, same light, different worlds, that is the finding. Photons are neutral. Models are not. That gap is frontier. We track every JWST dataset. Subscribe for MIRI results. Honest answer about TOI-270d in 2026 we do not know. JWST at its honest frontier, absolute limits of knowledge. Complete evidence breakdown pinned in the comments.